Welcome to EHJ Today. I'm Filippo Crea, Associate Editor of the European Heart Journal. I'm in Davos for Cardiology Update 2017, and I'm sitting with Tom Lüscher, who is the chairman of this very, very important meeting, and also the editor-in-chief of the European Heart Journal. And the topic today is fascinating, the microbiome. Pre-Socratic philosophers in ancient Greece proposed that we are what we eat. Now we are learning that we are what is eaten by our microbiome, by our microbes in the gut. Is this paradigm shift true?
Well, that's of course quite a question, but I think what I find fascinating is that we have trillions of organisms in our body that live with us, and they digest what we eat, and some are good things and some are maybe not so good things, and it influences our body in the positive and negative fashion.
And the weight is about 2 kilos. It's a large,
it's huge. And it's 3 times as many cells as we have in our that make up our bodies.
So must be important.
It's huge, yeah.
What is the danger signal which can start from microbiome?
Currently, the focus is on a substance called trimethylamine oxide, which is a product of lecithin or phospholipids that are cut by lipase in our belly, that then ends up with a smaller compound that is further reduced to trimethylamine by the bacteria, and then goes into the portal circulation, where it is oxidized by the liver by enzymes called FMO3, and then it circulates as an oxidized form in our circulation. And so far, the animal experiment suggests that it actually facilitates plaque growth. It may also activate coagulation, and so atherothrombosis may be negatively affected by this compound. So this is one of them. But there are other ones. There are also flavanols that are changed into urolithin A, which has been shown in rodents and in C. elegans to actually prolong life. So there are many things that are produced by the bacteria, and as we have 500 to 1,000 different bacteria in our body, the composition of it may be more important than just the sheer fact that we have it.
What about the danger signal, in particular TMAO? Do we have clinical evidence that increases cardiovascular risk?
Yes, I mean it has been measured in large cohorts of patients with stable coronary artery disease, and now we also have one in the European Heart Journal that is just online, in patients with after acute coronary syndromes with the Cleveland Clinic. Most of the work comes from the Cleveland Clinic, and there is a strong signal that the higher your level of TMAO, the worse is the outcome. And mostly these data have been presented in quartiles, and the highest quartile of TMAO seems to be particularly predictive. And what was also very interesting was that we had a Swiss cohort and an American cohort, and the TMAO levels in the Americans were much higher than in the Swiss. Maybe because the steaks are better in the US than they are in Switzerland. And also the event rate was higher in these guys. So I think that's quite an interesting correlation. But of course, this is not yet causality in the proper sense. The causality comes mainly from 2 lines of evidence. One is in the rodents, it has been shown that the higher the TMAO, the more plaques the animals develop. And the second evidence is also that in humans, and this is only indirect, that if you give antibiotics, the TMA signal disappears. And if it's there, it also relates to the extent of coronary disease. So if you have 3-vessel disease, you have higher levels than if you have single-vessel disease. But of course, we would need an interventional trial to actually show that this is causatively involved.
Well, waiting for randomized trials, another way to test causality, Mendelian randomizations. Right. Do you have data?
Yes, I mean there is a polymorphism of the FMO3 gene And in fact, there is a human disease, subjects that lack the FMO3 enzyme or have a mutation that makes it dysfunctional, they cannot oxidize TMA into TMAO. And they have a very bad smell, like rotten fish. So it's a rotten fish syndrome, as they're poor individuals. I'm not aware that the disease is frequent enough to make any judgment on that. But in animals, in mice, they have shown that if you have animals that don't express FMAO3, they have less plaques than those who do. So that there is some experimental evidence, but in humans, I think the mutations are not frequent enough to do a Mendelian randomization study at this point.
And what about the impact of microbiome on other risk factors like lipids or diabetes?
Diabetes has been shown that diabetes is adversely affected, and also non-alcoholic fatty liver disease is adversely affected. TMAO also has been shown in patients with renal disease to be a negative predictor. I think that's about what we currently have in terms of associations.
And what about variability among individuals? Do we have people with good microbiome and others with poor microbiome?
Yes. The first microbiome you get from the milk of the mother that lactates you. Must not be the native mother, but it comes from the mother milk. And of course, then it depends what you eat. So the interesting difference is between omnivores like us and those who are vegans or vegetarians. The vegetarians have markedly lower levels of TMAO, and also if they eat a meal, there's hardly any change in TMAO. Well, if we eat, lobster and spaghettis and some cheese on the spaghettis and maybe some eggs with the salad, then we have quite an increase in TMAO.
But something doesn't fit. For instance, we know that fish increases TMAO, that seems to be protective, or neutral at least. Yes. How do you explain this?
That's a difficult question. It is true that fish contain a lot of it. And the second paradox is that after gastric bypass, which improves diabetes, which improves many other cardiovascular and metabolic factors, TMAO goes actually up. But I think there is such a complexity. It's like genes. I mean, we have thousands of genes. We have thousands of different bacteria, and that they digest things in a different way. And so I think it may be the overall composition of what you have in terms of your microbiome that eventually gives you a final effect. And in spite of the fact that TMAO goes up when you have gastric bypass, if you take the microbiome and you feed mice with it, they don't gain weight, while if you take the microbiome of the same patient before gastric bypass, they will get obese. So the composition can change, and TMAO is only a glimpse of it. It's like nutrition and genetics that is so multifactorial that we cannot explain everything just with a single marker.
This is the complexity of biology, but
Absolutely.
It's really a new exciting field, and we look forward to listen more from you. Thank you very much, Tom.
Thank you, Filippo.